Okay, so it's 12 on my end, 3 p.m. everywhere else. Let's kick things off. I just want to say a quick hello and welcome to everybody. My name is Arpana Vania. I am the chair of omics, which is an interest group of MANA. Women in Metabolomics is what we're known for, but all are welcome and we're very happy to have everyone. Today, our moderator for our session is Miriam. So with that, I'd like to give her the floor. So thank you, everybody. Please feel free to add your questions to the chat. I'll be monitoring that.
Hello, everyone, and thank you for joining us for this month's Womex Images of Success seminar series, where we will hear from 3 experts in metabolomic centers and cores in North America. I'm going to give a quick introduction on our organization and Womex. Then I will hand it over to our 3 panelists, Dr. Lee from UNC Chapel Hill, Dr. Belinda Willard from Cleveland Clinic, and Dr. Coward from Virginia Commonwealth University. And then we're gonna open the floor to your questions that you submitted through the registration link, or any live questions that you want to ask our panels, and then we'll have a quick wrap up at the end. As Arpana mentioned, Womex is an interest group of Metabolomics Association of North America, which was established in 2017 to promote the growth and development of the field of metabolomics in North America. Our 3rd annual conference is scheduled for October 18th through the 21st, and it's actually a virtual conference, and it's hosted by Ohio State University. If you are interested, please visit the link that you see on the slide. Our current president is Tom Metz, who's been very supportive of our diversity and inclusion mission, and it's actually that has been instrumental for shaping Womex and Women in Metabolomics, where X is to explicitly welcome trans women, gender fluid, and non-binary participants. As Arpana mentioned, even though our seminars are open to the public, our focus remains to promote the professional development and engagement of women in metabolomics. Womex Organizing Committee is listed down below, which is led by Arpana Vania, who's doing the behind the scenes activities today and monitoring the chat. I want to briefly mention Womex Mentorship Program, which was recently launched to fulfill our mission statement by providing engagement of women in metabolomics. If you like more information, please write to us. If you'd like to join the mentorship program, let us know as well. And Womex was really a grassroots effort, which now stands as a solid platform for MANA's newer initiatives and interest groups, such as Metabolomics Core's Interest Group, which was launched recently to promote leadership and mentorship skills among our members to help them navigate common challenges and barriers faced by core staff. And also to facilitate communication among some 90 plus core laboratories across North America. If you like to join this interest group, we have a Google survey. We also have a call scheduled for late May. If you're interested, please write to us at cores@metabolomicsna.org, and we will add you to our list, and you can attend our call in May. Today, we're going to briefly touch on the pivotal role that metabolomic cores play in promoting science and technology, and also the community service they provide in terms of education. And while that is something that the cores do for our community, a lot of core staff don't get the credit they deserve, especially the early career core scientists, for their multidisciplinary talents and sophisticated level of fluid intelligence. So today we're going to hear from our three panelists on the good, the bad, and the ugly of working in a metabolomics core, not to scare or deter anyone, but to kind of put the focus on shaping the interests of a new generation of core scientists grounded in a more realistic career expectation and proper training. So with that, I'm going to turn it actually, I'm going to go over some housekeeping items, which I'm sure everybody knows by now. Mute your mics, consider turning off your video to preserve bandwidth. During the Q&A portion, please put your questions in the chat, and then we'll call your name and then you can ask your question. And Dr. Lee?
Hi, it's really my pleasure to be invited as the first speaker. So as you mentioned that I'm one of the members of an early career core scientist. I guess I'm still in early career stage, less successful than the other core leaders and directors. But I guess my experience pursuing my career in metabolomics might provide some help for someone in a similar stage or even earlier stage than me. So let me try to introduce myself a little bit. My name is Yan Lee. I'm currently an assistant professor in Nutrition Research Institute at UNC at Chapel Hill. So this is the slide that covers my general career journey since 2003. So as you know that I originally came from mainland China. So my first degree was on pharmaceutical science, which focused on promotion application of herbal medicine in disease prevention and management based on the evidence-based science. That's the motivation why I want and love science so much. So my first project is about using the leaf of the herbal plants to cope with infection disease such as SARS. And we found that the major mechanism for the herbal medicine is actually to reduce the inflammations and the cytokine storm, but not directly kill the virus. Thus, it can preventing the severe symptoms. I think this herb is still using in China these days for coping with the COVID-19, and definitely more science, more evidence need to be discovered. Then I shift my research to food engineering. I guess most of you here knows about truffle, right? It's a very expensive mushrooms with special smells. At that time, we used fermentation approach to produce the mycelium extract to simulate the flavor and the nutrition ingredients for the truffle. So at that time, my research is to use the fingerprint approach to profile the flavor and the nutrition compositions, thus provide guidance for the fermentation in the process improvement. That is actually part of the metabolomics, but at that time, I literally did not know what metabolomics is, but that is the nature of metabolomics. So in 2010, I did a big package of scholarship moving to Hong Kong for my PhD program. So I moved my research focus back to herbal medicine and natural products. So my PhD program is mainly focused using an herb called lysicortex for diabetes management, including finding what is the bioactive molecules and how the herb is working. So it's very interesting. So we found that the herb is actually not directly regulate the blood glucose. It just gave me a question mark in my mind of how it works. At that time, I went to a talk was given by Jeremy Nicholson in Imperial College. That's the first time I know that, wow, that is a powerful tool called metabolomics existing. Mike can play an important role to unlock the secret of herbal medicine. So having that kind of a motivation, I started to join some conference and talking to scientists working in the field. So in 2015, I met Dr. Susan Sumner, who is my mentor for my whole life until today. That changed my life. So from 2016, I moved to the US, working with Susan for my postdoc training, started to really learn and use metabolomics in research. So I use this powerful tool to study how the lysine cortex, the herb I study in my PhD, how it intervened the diabetes based on the animal study. Yeah, it's true. It does not really directly regulate the blood glucose, but it actually help to maintain the homeostasis of the metabolic profiles. That is why for long term, adjust the metabolism to help the body getting normal again. So this finding has been published in Frontier Pharmacology. If you have interest, you can go there to look at our researches. So since May 2017, I moved with Susan to MRI, which is in UNC at Chapel Hill. So we expanded the metabolomics to exposonomic platforms and adjust my focus on precision nutrition. So I also expand my research focus on the dietary exposomes, pregnancy complications, metabolomic syndromes, and opiate addictions. It really used metabolomic as a tool in a broader area for science. So not just for natural product research. I just want to use this platform to express my greatest grateful to my mentor, Susan Sumner, who gave me a chance to really change my life and get into a new stage of my life. Now I'm becoming a faculty member in the Nutrition Research Institute. And, when you're getting another level of the platform, it really can help you see a little bit further, improve your visions. And I would say that it's something, your career development. I guess that's pretty much I share for my research journey. Thank you.
Thank you. Belinda, would you like to give your introduction?
Sure. So again, thank you to the committee for inviting me to talk to everyone today. As you're going to see from my career path, is I've sort of stayed in the same geographic location my entire career. And so I'm originally from Northern Ohio. I was born and raised here, about 45 minutes from where I currently work, about 30 minutes from where I currently live. After high school, I went and did my undergraduate work at Mount Union College, which is still in Ohio, where I was a chemistry major. And when I went to college, my original career goal was to be a high school teacher and a high school basketball coach. But about my junior year of college, one of my professors pulled me aside and asked me if I went to graduate school. And to be honest, I had not. It had never even occurred to me. So I applied for the NSF-REU program. And so this is a research program. It's a summer program for students who go to small liberal art colleges. And so I did that the summer of 1993, so between my junior and senior years of college at the University of Kentucky down in Lexington. And while I was there, I studied nuclear chemistry. I used an instrument called a Van de Graaff accelerator, which is like 3 stories tall. It was really cool. And I enjoyed my summer very much. And I came back to school and I decided I wanted to go to graduate school, but I knew that I did not want to do wet chemistry because I hated it, but I really liked instruments. So I applied to grad schools and I ended up going to Carnegie Mellon University, which is in Pittsburgh, Pennsylvania. So again, not very far from where we are right now. At Carnegie Mellon, I ended up working in a mass spectrometry lab. And what I studied as a graduate student was essentially gas phase ion chemistry. So we had a very old instrument called a ZAB mass spectrometer, and I spent 5 years studying how ions fragment in the gas phase in a mass spectrometer. After my postdoc was finishing, I should mention along that time that I had my first daughter, who's the one holding the cat there, and my second daughter, who's the one in the middle, was on her way. And so when trying to decide decide where to do my postdoc, I had to decide between staying in the field I was currently in or sort of locating to a particular region. And because I had 2 small children, and my husband had a job in Cleveland and I had help here, I decided to look in this area, in the Cleveland area, for a position. And one of the positions that was available was a postdoctoral position in the proteomics core at the Cleveland Clinic. So I joined the proteomics core in 2000 and have never left. So throughout my postdoc, I ended up having daughter number 3, who is the one in the dress. That is her prom picture. Don't tell her I used that particular picture. And in 2008, the current proteomics, the previous core director decided to move, and they asked me to take over the core. So I took over as director of the proteomics core in 2008. And you can see below the Cleveland Clinic, there's a picture of an LTQ ion trap instrument, which was our main instrument at the time in 2008. And in 2014, they decided to merge the proteomics and metabolomics core. So I took over directing the metabolomics core in 2014, and there's a couple of thermo instruments there, one GC, one LC instrument. And I've been sort of directing the proteomics and metabolomics cores ever since. And I'm happy to give you some insights, I guess, into working in a core. I'm going to be honest with you, I've learned a lot of this through experience. When I started in 2008 as a director, I did not have a lot of mentors or people I could ask questions about how to approach things, how to deal with investigators, how to get new instrumentation. So I spent a lot of time making mistakes and learning as I go. And so I'm happy to give you what advice I may have.
Thank you. Great introduction. Dr. Kowart, would you like to unmute and give your introduction?
Hi, sure. So I did my undergraduate work at Furman University in South Carolina. I'm a native South Carolinian. And similar to our previous speaker, I got interested in graduate school based on one of the NSF REU summer internships that I did. And I did a more biology focused internship. So I was very interested in biology. My career goal at that point was to be a small private liberal arts science professor. And I knew I needed a PhD degree for that. And I went to Vanderbilt University and did my PhD. And between 1995 and 2001, when I was doing my PhD, I really caught the research bug. I got to go to a couple of conferences. I got really fascinated with being able to figure out real unknowns. Not that teaching, biology 101 is not exciting, but you are sort of imparting a lot of knowledge that's already known. And I really felt like my passion was for finding out unknowns. So I've been in lipids my whole life. So at that time at Vanderbilt, I did use a lot of chromatography and mass spectrometry approaches, but they were not high throughput. We were just following, trying to quantify and identify compounds that we had a really good idea about what they were going to be. So I knew I wanted to stay in lipid research, but the icosanoid field was very, very crowded, and the culture of the icosanoid field at that time was, I guess, a bit intimidating for a beginning scientist in her mid-20s. There were a lot of very senior people in real power labs and a lot of politics. So I wanted to stay in lipids so I could still use the expertise I had developed there, but also maybe get into a new area. And I started looking at different lipid classes and different areas of lipid research. And at that time, sphingolipids were emerging as new novel cellular regulatory molecules about which very little was known. Many of the enzymes of sphingolipid metabolism were not even cloned at that time. So there was just a big, wide world of sphingolipids waiting to be discovered. So I joined the lab of one of the leading scientists in that field, Yusuf Hanoun, who was a fantastic mentor. Gave me a lot of wonderful opportunities. So I did my postdoctoral fellowship there. And again, we did a lot of chromatographic and mass spectrometry approaches. And at that time, we were getting into a more high throughput situation where we could measure 100 sphingolipids in a single sample using LC and tandem mass spectrometry, but it still wasn't the untargeted, unbiased kind of approaches that most of the cores think of now when you say metabolomics. But we were doing a targeted, semi-targeted, high throughput lipidomics. So I stayed on at the Medical University of South Carolina. I got some funding from the Veterans Affairs, a Career Development Award. And so since then I've maintained a Veterans Affairs appointment, which has also been a real nice bolster for my scientific career, having the two funding sources, and the two appointments, the dual appointment. So I stayed at Medical University of South Carolina until 2016. I left in 2017. I was, at that time, I was an associate professor with tenure, and then I was recruited to Virginia Commonwealth University, and the director of the lipidomics core there had taken a different position, and so I overtook the lipidomics core at VCU. And I've now been expanding that into untargeted polar metabolites. So we're actually just in the first couple of years of developing our polar metabolite untargeted metabolomics platforms for our users. And I think we're starting out having some success. So I came into a lipidomics core and I was pretty much familiar with their procedures and the user needs and all of that. But the Cancer Center and the user base at VCU was really craving a polar comprehensive metabolomics center. And so that's what I've been developing for the last 2 years. I procured instrumentation for that, a thermo instrument, through the state of Virginia has a plan, has a program where institutes of higher education can get grants for high-end instrumentation. And so that's how I got the instrument. I'll say that I'm married and I do have one daughter, and I had her in 2009 while I was at Medical University of South Carolina, and timed her perfectly because I had just gotten a VA grant, and then I had her just a few months later. And so that was just absolutely perfect timing. I know that timing of career and family kind of comes up in these sorts of fora. But anyway, so that's kind of the journey about, that's my journey and how I came to be where I am.
Thank you. That was wonderful. And now I'm going to open it up to the participants. Arpana, do you have anything in the chat?
Nothing in the chat so far, but we could start off with some of the pre-submitted questions.
Sure. I'm going to actually start with something that is one of my favorite questions that was submitted through the registration.
Before you start, can we do the stop share and then have it on gallery view? Perfect. Thank you.
Okay. Okay, so I'm going to read one of the questions that I like the most from what was submitted to us. What are your suggestions for early career scientists who are going to pursue a career in a metabolomics core? Who's going to take this?
I guess I can start. So suggestions for early career scientists if they want to work in a metabolomics core, correct?
Yes.
Yes. Okay. So, I think my suggestion would be is to participate in forums like this, where you get a chance to ask people that are doing it what is good and what is bad about working in a metabolomics core. So there are some benefits of working in a core, and there are some hurdles. So I would start there. I would also encourage you to widen your field of knowledge, right? So the one thing about working in a metabolomics core I found is you have to know about a lot of different types of experiments, okay? You have to be able to do targeted metabolomics, you have to be able to do untargeted metabolomics, you have to know about lipids, and you have to know about the different techniques, LC versus GC. So just sort of and ask questions and really get a feel for you know, how you might fit into that environment. And so some of the skills I think that have been useful to me in the core is the ability to work as a team, obviously, but one of the things that is very important is communication. So sitting down with someone, getting them to tell you what their goal of their experiment is, and you helping them identify the best way forward to meet those goals. That's a very important thing to learn. And it's something that I was not at when I first started, and something that I've continually had to work on is communicating with investigators. You know, and the one thing about being a core that may be different than what some of you are used to is it is like running a small business. And so you have to sometimes think about it as a business in some ways. And that has been one of the most challenging things for me in working in a core is you can't always just think like a scientist. Sometimes you have to think, you have to approach it like a business, just in terms of budgets and funding, and you know, when do we take an old piece of equipment and sunset it? When do we bring in new equipment? That sort of thing. So.
Thank you, Belinda. Does Jan, do you want to comment on that as well?
Yeah, I think Brenda has already answered most of the aspects I want to mention, but I want to highlight one thing: the communication is the key. Because I'm a early career scientist, I think that's the most important thing for me. So the communication means that you need to communicate with the collaborators, what the samples, what the study designs. You need to really understand what is the goal our collaborators want, and you need to evaluate that whether that person's goal and then the real world from answers from the instruments, the metabolomic can whether well match with the goal he or she wants, and better communicate upfront before the result come out. It's make sure that the expectations are aligned. I think that's very important, because metabolomic is a powerful tool, but it's not that powerful can help everyone go to the moon. So that is things I want to add on. I'm glad everyone is laughing.
And I would agree. I would definitely second everything Belinda and Juan said. And as an early career scientist or as a postdoc, if your goal is to get involved in a lot of metabolomics, I would start by getting involved in a lot of metabolomics and try to collaborate and be involved in as many omics related projects. Even in my postdoc, I did a lot of transcriptomics, and while that's not technically related, a lot of the issues of communication and the bioinformatics are very paradigmatically aligned. It's a big word for Friday afternoon. But a lot of the ways of thinking about data are similar. And so get yourself involved in as many of those projects, because the best way to be able to communicate is to understand all these different kinds of approaches that people are taking.
Thank you. I see a question in the chat. Shanok Russell, would you like to unmute and ask your question?
Sure. Yeah, so Belinda, you briefly talked about this, but how do you, as directors or working in the core, balance the business side of it with the science and progressing research forward?
Sure, I can start on this. And so in terms of the business side of things, and so as a lot of cores are, my cores typically we run as fee for service, and so we charge people to utilize the core. And what we try to balance in the charging is we have to recoup a certain amount of our revenue but we also want to make the experiments at a price rate that the investors can actually do them. So you're constantly balancing those two things. And so, you know, it's our primary goal is always the science. We want to help investigators get data for manuscripts and for grants. That's our ultimate goal. And sometimes, you know, that doesn't always work with running the core as a business model. And so I always try to juggle those two things. What some of the things we've done at the Cleveland Clinic and some of the institutes around us is they have little pilot awards for young investigators. So if you have someone just coming in, they can apply for some pilot awards and get some money that they can then use to do their experiments within the core. But in terms of how you juggle it, I always put the science first, and to me, the business is always second. But I work closely with the administrators and the MBA we have in our that I report to, and you know, talk about that. And I communicate, this is what I need to do good science. What can you give me on the budget side to make that happen? Okay.
Excellent. So I'm going to move on to a more difficult question, something that I struggle with sometimes. The question is, how do you overcome low confidence issues yourself or your staff in a male-dominated research setting? Ashley?
Okay. So I'm actually our core director, but the person with more of the really nitty gritty technical know-how and the analytical chemist is a man. Yeah, I'm still his boss, but I think he and I make a great team. And I'm the one that's better at, or that handles the communication and understanding the end need of the user. And he's, you know, I'm kind of the intermediary. So I think the two of us together are both a pretty effective team. In terms of confidence, I think anytime I've had times of low confidence, I've just had to do some reflection and have a reality check and realize that maybe I was internalizing something or thinking something about myself that wasn't necessarily true. So if we have, for example, a really unhappy user who didn't like their data, who thought the turnaround time was too long, I just had to have a reality check that, you know, I'm sorry that their experiment didn't turn out how they wanted, but the data are solid and we did what we could. The turnaround time was long because 5 users submitted huge amounts of samples all on the same day. And I'm actually now trying to focus on how proud I am of our small team and how well we do serve as many users as we actually serve. So the complaints don't bother me so much. I would also say that in the administration, everyone I deal with is male, but I don't feel any, I feel nothing but support really for my facility. Historically, we've been a very important facility, partially because of our lipid focus, and VCU has a long history of lipid research. And that's a subset of metabolomics that does require a little bit of a little specialization in terms of how you handle the lipids and how you talk about them and stuff. So I think, you know, every now and then, if you start feeling not confident, you just have to have a very logical, non-emotional reality check with yourself and talk to yourself as if it were your best friend who was in the same situation. And what would you tell her? That approach helps me a lot, actually.
That's great advice.
Yeah, I'm going to share some of my opinions on that. So when I was growing up, I was not a very confident person. And one day, I think I talked to someone who's much senior than me, and then just like I have the aha moment, knowing that, you know, the confidence is not given by someone's improvement or credit. It should coming from yourself. As long as you're comfortable what have you done, you don't feel guilty about yourself, that is enough. I mean, I would say that, I think the gender difference is not the only issues in the US. I think it's in every countries. I mean, I don't want to use the word discrimination, but I guess most of people in this world are pretty nice and helpful, because if we're working together, our goal is not to discriminate each other. Our goal is to make the work done, make the business successful, make the science successful. So as long as you can pull the goal when you communicate with that person on the same page, most of the things I personally I can solve it pretty smoothly. I mean, I used to, deal with some of the vendors or maybe the engineers who was men. They don't really trust me because I'm a lady, Asian small lady. I mean, looks very young, no experience. So, I mean, I won't take it personally. I would just smiling and telling him that what I think and show data instead of saying that, well, you should trust me. Let's talk the data, how the data reflect the truth. And then I only want this instrument achieve this data. So I think the problem is A, B, C, and D, as well as you present it with the evidence-based results and clues, and you have your goals clearly, what you want. I think most of people's you can deal with. I would say that this kind of a very ridiculous, crazy, cuckoo and jerk, it's extremely minority. So we should put our attention and our focus on those nice peoples, but for those kind of extremely small percentage of jerks, you can walk away, because walking away is the most powerful tool when you are in negotiation. So that is what I want to share, and be strong by ourselves and don't take anything personally. Just focus on science and work, less sensitive. That's very important for not only women scientists working in the core facility. I think it's actually a key that we can all survive in this human world, human life.
Thank you. Belinda, would you like to add to that?
Well, I think Ashley and Yuan both said that very, very well. The way so first of all, I would say that I've had very few instances in my career where I've felt like being a woman has set me back. Having said that, though, most of my experiences where I felt like being a woman I was being discriminated against came outside of my work. Okay. And I've always dealt with those situations by using them as motivation to basically do my job or do whatever it is better. Okay. So anytime somebody doubts me, whether it's because I'm a woman or because I run a core or whatever, it just motivates me more. And so I think in terms of confidence, again, as Ashley said, just self-reflection, knowing that you're not always going to do everything perfectly, but there's always use setbacks as an opportunity to improve and learn something and get better. So my whole life, if you doubt me, that's good for me, because it just makes me work harder.
Thank you. That was great. So this question, I believe, came actually from Ashley, but we had a similar question from one of the registrants. Is it difficult to manage and develop a core in addition to directing your own laboratory?
Yes. Long story short, yes. I have a lab which at its largest had 7 members. Right now we're down to 4, thankfully. The one thing that has made it easier is that all 3 of those projects use lipidomics and they use metabolomics. So I can't use my own core for free. That's against every regulation. I have to treat my own people's samples as if they were outside user samples. But that keeps me really connected and in the loop with what's going on in the core and how samples are running. And also I have a lot of collaborations, as most people in a similar position, career position to me would have. I have a lot of collaborations both at VCU and externally that use the core. And so in that gray area is where it's easy, because it's very overlapping and I'm killing two birds with one stone a lot of times. When it's difficult is when I'm in a part of a project, you know, having difficulty making a mouse, or, you know, trying to figure out a signaling pathway, nothing really core related. And then an instrument goes down and 5 users are unhappy. And so there's the nice, happy gray area, but I do find myself in both extremes often. And it's just a matter of not even time management, I would say, but just my mental bandwidth management, and just setting aside time to play, to have two hats. So I would say I have a lab hat, I have a core director hat, and then I have a happy in the middle. That might be where I wear no hat. I'm just me, but it is, you do have to put a lot of effort into balancing that, but it's possible.
Miriam, I have a question to kind of bounce off of that. Since you do have two hats, Ashley, how do you motivate your researchers and core staff, since they have different career trajectories? And, you know, how do you help them with their overall career objectives and dreams and, you know, all of that stuff?
So my trainees in the lab are excited about the science. I think they're excited about their projects and where we're going with understanding how sphingolipids contribute to pathology and liver and adipose and heart, which is what my lab works on. In the lab, the core personnel there are excited about new technology and how we are helping the research community. So for example, the other day we got an email, and I'm only telling you the happy side, okay? It's not always 100% happy, of course nothing is, but we got an email from a long-term collaborator saying, we just got a giant grant funded and we're gonna be using you for all of these sample analyses. And that was a real, that was really encouraging for us, because it lets us know we're doing something that's helping science move along, and it's going to contribute to the body of knowledge that humans have, and you know, maybe better health outcomes and stuff. And so I think the goals of the core personnel are to have a good core that's running really well, that's making a contribution that's tangible. And when you see papers published and when you see grants funded, that's tangible and it's deeply rewarding. And then on the other hand, in my lab, my trainees, my PhD students and postdocs, we're just excited when we move our science forward. So it is two different worlds, but the motivating factors are different, but things fall into line, I think, if you recognize the goals of each group.
So we have a question in the chat from Rebecca. Would you like to unmute and ask your question, Rebecca?
Sure. I just wanted to thank everyone so far for just being here to share all of their experience and wisdom. And my question just comes more for those labs that are mainly just a core, or providing a service to a large amount of other research groups. Do your researchers and postdocs and technicians even maybe have a lot of time that they use for implementing new technologies that comes along in other type of developmental projects? Or is it that the lab is always swamped with samples coming in from other investigators? Is there a split in their time, and maybe about how much time is spent doing this versus collaborating with other investigators on their projects?
I can take this one. So again, you hit the nail on the head when you started talking about swamped with samples from other investigators, because, you know, because our mandate is to help researchers, you know, with their experiments, you know, we have to prioritize that. Having said that, though, what we really try to do in our core as much as possible is use those projects to help us develop new methods and technologies, okay? So if someone comes to us with, a set of metabolites they would like to target for quantitation and we don't have a method for, then we will do some method development. And we're always looking for we can do things better. So if we identify, a set of researchers who have similar interests in the same set of metabolites, then we might set aside some time to do some more in-depth method development to help that particular group of researchers. And what I found is when we take time to do that, to really put the effort into developing new and better methods, it pays off in the end. So you'll end up improving how you do something or adding a new method or technique, and then helps other labs down the line. So it's a little bit of a juggling match or juggling job to try to get enough time to do your own method development that will in the end help the investigators, but also make sure you're keeping up with your current samples. And it's always a struggle. I don't know if I've ever found the perfect balance, but it's something we continually work on, and something when I get a chance to talk to the leadership, I indicate that that's something that we really struggle with, and try to identify ways to improve our ability to develop new methods, make them available to investigators, but at the same time, get through our sample load in a timely manner.
So this is Jan. I am not the director level or full professor yet. I'm still early career, but I would like to share some of the things my director, Susan Sumner, has been doing to help the early career scientists growing. So basically in our core, we say our laboratory, we have a lot of collaborations with different professors, but we prioritize the projects that align with the young scientists' interest or the whole group's interest first. And then I think my director is doing a really good job there to negotiate the credits for every people working in the core as a young scientist to help them growing up. For example, for me, so my career path with my mentor is that I will be considered growing as the next generation of a core leader. So I will get this focus on this path and get a specific training to see how can I manage the core and how can I develop the core in a further, including the method development and new technology development and new platform development. But some other postdoc or trainees, they have interests on cancer or have interests on other of the areas. They will incorporate their interests and negotiate with the collaborators. When we have the results, we can work together to apply fundings, and gradually these credits and the future fundings will be beneficial for someone who is young but working as a scientist in the core. So it's really the wisdoms of the leader. I'm not there yet, but I think my director has demonstrated a good model that, in future, I will trying to learn and grow myself there or have a better way to think about it.
Ashley, would you like to add to that?
How are we on time? I don't have too much to add. I think one, and Belinda did a great job. I think it's something that you do along, as Belinda said, as users need new services, then that mandates that you have to develop those methods and those services. We, in our situation, developing the metabolomics, the polar metabolite analysis, which is a completely different world than the routine lipidomics we'd been doing. That just came out of not one or two user need, but our cancer center said we would like to be able to do cancer metabolomics. But it has, it does slow down it does take away, and it's like Belinda said, you never find a perfect balance maybe, but there's time to do both. And I think that both are appreciated as valuable by the institution, because as you develop more services, if you have a demand for those services, then it just helps your, help support your user base at your institution.
Another good question that we collected was how is fee for service versus collaboration addressed or decided with users in your lab?
I can answer that one because it is something that comes up a lot in my core and in other cores at VCU. Pretty much we're always fee for service unless it is a collaboration I would have had, even if I'm not the lipidomics core director. So there are a couple of those that I have. I have a big heart project and I have people in the heart community and we'll want to do a project that involves sphingolipids. And so then, you know, I'll pay for those to contribute the data to that part of the project. On the other hand, some of, for example, the newer stuff we're doing, the polar metabolite analyses, if I have to be very, very intellectually involved, then it's sort of a given that it's going to be shared authorship and collaboration, but we still would charge the user. So there is a fuzzy area in there, but I think it's dictated by my level of intellectual engagement. So we have users who we're just a black box. They send us samples, we send them an Excel spreadsheet, and that's the end. And that's fee for service, purely transactional, and everyone's happy and it's fine. But then we do have people with new things they want to measure or different approaches they want to use. Then it becomes a bit more nuanced, and often the authorship is shared. Even with one group, a few groups I collaborate with, sometimes they want direction on where they should go with their project, but it's because it's related to what I do in my lab. So I provide a lot of guidance, you know, hey, you saw that this increases, maybe we should look at this enzyme, that enzyme. So even though they're paying and it is fee for service, it's also collaborative. So I think it ranges in my situation from pure fee for service, I may not even know what someone's project is, all the way through to so collaborative that I'm actually paying for it, and that's my contribution to their project. And there's a huge spectrum in between. And by me paying for it, I don't mean my core paying for it. I mean me paying for it as a collaborator from my grants and other resources.
So I just would like to add on to what Ashley's discussed about that. So this is an interesting topic because it's something that the core directors at the Institute have been discussing now for a while, and we've actually started to set out guidelines in terms of what constitutes fee for service versus what constitutes a collaboration. And you know, and so with those guidelines, the things that we look at are, one, the size of the project. Okay, you know, if you're coming to the core and you're going to be running 50 samples, maybe that's not a collaborative interaction. That's going to be more fee for service. But if you've got a larger project that's going to require multiple samples over a long time, and you really need the inputs of the expertise from the core to really move that research forward, then it becomes more of a collaborative project. And what we do with the collaboration is we still have to charge for access to the instruments and other things, but we have a you know, we work out a fee structure with the investigator to make that more doable. And usually collaborative projects do include grant support for personnel within the core. And again, it's something we've, at the research at the LRI where we are, have been discussing now for probably 6 months to a year. We're finally to a point where we have some guidelines down that the core directors can use and give to the investigators and say, this is sort of the difference between fee for service and collaboration. And so they kind of know what they're getting. A lot of investigators here really think, do the collaboration because when they think the expertise will help them with their grant applications and things like that. And so it's a constant back and forth, but I would say 80 to 85% of our work is fee for service. You know, we have collaborative interactions, but they're usually not the majority of our interactions.
So just to keep us on time, Jenny posted a question in the chat if you'd like to quickly ask your question. Or I can read it.
Yeah, so I have a question. So because some of you are PI or leader or core manager, so when you have a career goal of becoming a PI or leader, but you are not very sure if you are going to be a very successful or really a real PI, and will you be very anxious and upset on the road of becoming because of uncertainty? And how do you adjust yourself on this road?
I think I can understand. I can answer these questions. I mean, I think I'm not that kind of person has a very clearly goal that, I will be the president of somewhere, but it's sort of like, step by step. It's not such a thing that you can jump from zero to somewhere in one day or maybe in a month. It normally takes years. So I will see each of the days and each of the efforts step by step as a solid improvement instead of only, overly focus on what might happen, what the results might be. So that probably can really help to reduce the anxious and upset. So according to my feeling is that the anxious and upset sometimes is coming from the expectation, and what you get is it's unequal, unmatched. That's why you hate yourself, angry about yourself. I will say that I will try to put myself down and appreciate everything I learned step by step. If the things will come to your life, it will come eventually. Just be patient and focus on what you gain in your life and knowledge, but not the critics and the crowns on your head. It will come. It will come eventually.
Wonderful. Thank you. Just to keep us on time, I'm going to share my screen last a wrap up slides so we can keep in touch. So Mana is quite active on social media. We have several interest groups. If you visit Mana website, you can read through the different interest groups and see if any of them really align with your research interests. And you can let us know if you're interested in joining any of them. We're on Twitter, we're on Facebook, all the good stuff. And I want to thank our panelists for taking the time out of their busy schedule and giving us their personal experiences and sharing some wisdom about working in a metabolomics core. I find it quite challenging and at times rewarding. Crowns on my head, I don't know. Belinda is my boss, so I will be expecting a crown in the mail sometime. But I really want to appreciate all of you for joining, and really this has given me hope and some really good advice because as we said earlier in the call, communication is the key in working in a metabolomics core, whether it's with your colleagues or if it's with investigators that walk through your door with random samples N of 1. And so, it's really challenging and rewarding at the same time. And with that, I'm going to hand over to Arpana. Is there anything that you'd like to add?
No, but if you have seen the chat, there's a lot of links. There was a link that I provided for the MANA core interest groups Google form, and also the when to meet for the May meeting. And then if you haven't checked out our website, we kind of have two ways that you can keep updated in terms of our future events. You can check out our website or just go directly through the MANA website. All of that information is up there. But also, if you'd like to join our email list, you can feel free to email me at our Womics email, or if you already have, if we already have each other's emails, like my personal email or whatnot, work email, you can always reach out that way as well. yeah, we're going to have another iOS Image of Success event in June. So, you know, hope to see all of you guys there. With that, you close the meeting and hope you guys all have a great weekend. Thank you for joining.
Thank you.